Today in this video, we're going to talk a little bit about what C# is. We're going to look at it more from a conceptual standpoint rather than a hard coding standpoint. So this is going to get you prepared for later lessons when we will go into more detail on some of these topics. But having a broad overview of what C# is can help you understand where all these pieces fit together when we do go into more detail. So we are going to be discussing the building blocks of programming, and the major areas that we'll be discussing are what are variables and how do we use them, the purpose of methods, classes and objects, and what is a unity component. So after this video, you should have a clear understanding of all four areas. First, let's talk a little bit about variables. What are variables, how do we use them, and some examples. So conceptually, you can think of variables as the most basic unit of programming. All programming languages have variables or the concept of variables, and you can't get any more simpler in a programming language than a variable. But practically speaking, we can think of variables like a container. For instance, a good analogy is a variable is a lot like a mailbox. We can create new ones. We can, we could put down new mailboxes if we needed more. We can put things inside of them. We can change what's inside of them, and we can also see what's inside of them at any point that we need to. So just think of a variable as a very simple container, kind of like a mailbox. One thing that we do need to point out, and this is going to come up a lot today in this video, is that names are important when it comes to C#. So each time you create a new variable, you're going to have to give it a unique name. And the reason is you need to know the name of the variable so that you can look it up later. There are a lot of rules to naming variables, but we're not going to cover that in this video. You will learn about that eventually. Again, if we don't have a unique name for our variable, how would you find it if you needed to see what's inside of it? Just like a mailbox, you could tell people go look in the blue mailbox, go look in the red mailbox, but rather than colors, we're just going to assign a name to it instead. As far as working with variables, a variable is meant as a placeholder for a value you are trying to store. And we can use variable names as a substitute for the values stored inside. And we can do a very simple example of this using some basic algebra. Let's consider the simple math equation of 5 plus 3 equals 8. Now let's say that we wanted to store the number 3 inside of a variable. We could create a new variable. In this instance, I'm going to call my variable my var and set that equal to 3. So now we can rewrite that first equation using that new variable we created this way. We would say 5 plus my var is equal to 8. So my var is just a placeholder for 3. Let's take a look at an example in C#. I have a quick demo scene in Unity where I have a script called demo script that I created and attached to the main camera. If you do wish to try it along, all you need to do to create a script is right-click and create a new C# script, and then once it's created, drop it on your main camera. We're just going to be doing a couple lines of code that is going to print some text to the console tab right here. So when I load up my script, I'm going to double click it to open up in Visual Studio. This is usually what you get when you start the script. So don't get too hung up on exactly what I'm typing. We're going to be covering a lot of this a little bit later today in this video, as well as in the next lesson. So the first thing I'm going to do is I'm going to create a variable. I'm going to say public int my age. I'm going to set it equal to 25. and I'm going to end it in a semicolon. I'm going to come down here where it says void start, and I'm going to use a line debug.log, and anything I put inside of these parentheses right here, let me quickly add that semicolon, will get printed to that Unity console right here. So for instance, I can easily write in double quotes, hello world, to print out that phrase to the console. I can also, with debug.log, print out a number. I don't need to double quotes, though. I can just write 25. I can also call that variable inside of there and have that print out as well. So I could say debug.log, and it is called my age. I do have to make sure I spell it exactly the same, including like the capitals and the lowercase and everything like that. So now if I save this and I come over to Unity and I hit run, first it prints out my phrase, hello world. It prints out 25, which was that hard-coded number in, as well as that variable which it was storing 25. We can make some alterations to this. For instance, maybe rather than my age, it wants to print out my age plus 1. So that maybe, you know, I'm a year older now and it needs to get raised. So it's going to take whatever is being stored in there, add 1 to it, and print it out. Very similar to that simple equation that we were looking at before. So now if I run it, I get my hello world, I get that hard-coded 25 and 26, which was my age plus 1. An interesting thing that we can see in here is if I go to my main camera, I can see my variable right here. Do you see how it's my age? And it has the default of 25 in there. The nice thing about this variable, it is a container. So we can alter what's being stored in there. So maybe, you know, I lied a little bit. I'm not 25, I'm 50. So now if I hit play, I updated what's in that container, so I'm not, you know, it doesn't say 26, the 25 plus 1. It's taken that 50 and adding 1 to it, so now it's 51. The next building block of programming I want to talk a little bit about is methods. Methods conceptually are how work gets done in an application or program. Without methods, the program can't actually do anything. But practically speaking, it's just another container for a set of instructions that run every time it's called. So we can put different lines of code in different methods, and each time we call that method, it runs everything in there. You can think of methods kind of like the bones of your program. If we don't have them, nothing's going to get moving, because that's how important these are. So some things about methods. We can take in variables in our methods. So if we need to give it information, we can output variables. So we can send out information from it. And methods can also have their own private variables inside of them that only the methods can look at and use. One thing to keep in mind is that methods are named too. So they need to have unique names just like variables. And they have their own set of rules with them. And we will kind of go over those in another lesson. But you can also think of a method like a placeholder as well. So if you use the name of a method in your program, it will line the code contained inside of it. Let's say that our program needed to add two numbers together. And this is a process that we do a lot in our program. So it would make sense to have a specific method that just takes two numbers and adds them together. So we could have a method called add num that has a first number and a second number. And methods are always, their lines of code are always encapsulated by these curly braces. So we can kind of add those in there. And all that it does is it would take that first number and add that second number to it. Oops, I'm a little messy today. And that's all it needs to do. So anytime we needed to do that, we could just somewhere in our code say, hey, add num. What numbers do we want to add? Maybe our 5 and 3. Maybe, and then we need to do it again. And we could throw any two numbers in here, 27 and 1000. We could even send variables with it as long as they were, holding a number. So we could do like add num, let's say like my var and my other var. And these would all just come to here. Oh, this is first. Oh, this is second. Okay, add those together. And it would just do that every single time we call this method. Let's look at it in code for a little bit. What if we wanted to always be able to look and see how old someone would be 1 year later? So we would want to give it an age, and then we would want to add 1 year to it and print out that new age. So down here in the coding I was working with before, I'm going to make a new void called 1 older. And it's going to take in a variable that is going to be an age. So all it does in here is we'll do debug.log, and it's just going to print out age, whatever number we get sent to it, plus 1. Oops, plus 1. A very simple method. So in order for this to run, we will need to call this method. And I'm going to come up here and let me get rid of this one. And I'm just going to replace these up here with that. So we're going to call it right here, 1 older. And then in the parentheses, we're going to give it an age, like a number. So we could send it, 50. We could send it my age. So now when it runs, the first thing it's going to do is it's going to print out debug.log hello world. Then it's going to see this method, 1 older. It's going to locate it down here. It's going to take that number and say, okay, we're calling it this now. This is a new variable in here. We're holding on to it. And we're going to print out whatever number is in this container, which in this case right now is 50, with 1 added to it. We're then going to go down to this one. It's like, oh, we're calling this method again. What age is getting sent to it? Oh, this number being stored here. So it's going to be sent, and it's going to print out whatever's being stored in this variable, which right now is 25, with 1 added to it. So we should see 26. So I'm going to save it. So now back over in Unity, I do want to make sure that I did mess with this. I changed what was being stored in that variable, so I do want to set it back to 25 since that's what I'm trying to look for. If I hit play, I get hello world. I get 51, which is that 50 plus 1, and 26, which is what's being stored in my age plus 1. The next building block of programming we're going to discuss are classes. Conceptually, a class holds related information and actions in a single container. But practically, you can think of a class like a blueprint, where it sets rules and regulations, and you create objects based on that blueprint, usually called an instance of that object, that are created based on that. An example would be if you had a blueprint of a house. You can set rules about what a house is, and you can set specific variables and parameters about it. So you could have a blue house, you could have a pink house, you could have a yellow house. Maybe you can have a 1-story house and a 2-story house. These would be all laid out inside of your blueprint. You wouldn't be able to have a cash register in your house because that would require a blueprint for a store, not a house. So you set limits on what can happen with it, but you need to make sure that you have enough rules and regulations in there so that you can get the work done that you need with your class. So if you have been working with Unity a little bit, maybe went through the first couple chapters in the book, maybe started and you're working along with me, you would have seen this word mono behavior. And every script created in Unity is actually a class. Like the demo script I've been working in is a class called demo script. And when you see mono behavior on a Unity script, it just means that your script can be attached to a game object in Unity. So if we need to make scripts for Unity specific things, we're going to be making scripts that are derived from mono behavior. We're going to go into this in more detail towards the end of the video. So again, classes are like blueprints. They are going to hold variables and methods that you define inside of there that are related to each other. So when you create an instance of a class, which might also be called an object, you can give it a unique variable and values and run its methods independently of other objects in the same class. So if we go back to the idea of the house, if you had a house class, you could have a number in there that holds how many floors are in your house. You could hold a phrase in there that has the home's address. You could have another number in there for the phone number associated with this house. You could even have like a number in there for how many bedrooms there are. And you would have methods then for things that this object should do. So for instance, you could have a method that turns on all the lights for your house. You could have a method that locks the front door. And you wouldn't want anything in there that doesn't associate directly with your objects. So like you wouldn't want a method about, like, for instance, driving your car down the street, because that wouldn't be something associated with the house. You would need to have a car class that would have that kind of method in there that would control your car. So I would like to talk a little bit about commenting code. While it's not necessarily considered like a fundamental block of programming, it's still an essential part of programming, and it's something that you need to make sure that you're doing as you code. More or less what you're doing are you're leaving notes in your code about what your script is supposed to be doing. And this becomes handy when you're working with other programmers. It's also handy for yourself so that if you are working and let's say you get interrupted, like the phone rings or it's the end of the day and you come back to it the next day, if you read your comments, it can kind of help you remember what you're thinking about when you come back later to it. There are two different ways that you can leave comments in your code. And the default script that gets created with Unity actually has a few in there to start with. Specifically right here, where you see these double slashes and the line start is called before the first frame update. This is a comment in the code. You can do single line comments by doing that // If you're working in Visual Studio, anywhere that you see the green code, like it's colored green, means that it's a comment. It's not actual code, so this does not run when you go back to Unity. Usually you'd want to leave a comment about, what a method is so that people understand what it's supposed to be doing, because you might understand what one older is, but what if you're working on a team and you give this to somebody else? How would they understand what one older is? So you'd want to leave a little comment saying this takes in an age and prints out what it would be if you add 1 to it. So very easy to understand. You might need to do multiple lines of code, and normally you would definitely see these at the top, so that you could put something in that's sometimes referred to as a header that has just general information about what this script is. So we can do multiple lines of code by doing a /*, and then anything following this is code. In fact, you can see that it turned my whole entire script into a comment. So I can, for instance, put my name. I can talk about, if this is for a class, you could put your class name. Most likely your instructor will have what you're supposed to be putting in at the top up here somewhere in the course shell, so I definitely look for that. We could say that, this is just a demo. And then when we're done, to close our comment, we do the //. So anything between here and here is a comment, so we can do a lot of lines of code with that. So please make sure that you are leaving comments in your code so that you know what you're doing when you come back to it, and other people know what they're doing as well. Let's revisit mono behavior and talk a little bit about it as well as some of its methods. So since our classes are built off of the blueprint of mono behavior, we can take advantage of some of mono behavior's methods. And you've already seen 2 of them if you've been playing with the script that Unity creates for you. Sometimes you might also hear these 2 things referred to as events, because they will run when a specific event happens during gameplay. So the 2 that you you see that are automatically put in are start and update. So start, this is the one that we've been using during this demo. This method runs when the scene starts playing. So when we hit the play button in Unity, when this script wakes up, it will run all of the lines of code found in the start method in your script. That's why we've been putting these lines of code inside of here. So we see the void start. So when we hit play, it will run anything we have in here and then stop. So this does only get called when everything starts. Update is a little bit different. This one runs once per frame. And each time the game updates, it will run all the lines of code found inside the update method in your script. So you have to be very careful about what you put in here, because you can get yourself in trouble real easily. And I'm going to demonstrate, this example right now. So let me hit pause. If we go back here, we haven't actually been using update. So I'm going to change, I'm going to make a new integer, a new variable up here, public int counter. I can set that equal to 0. And in update, right here, called once per frame, I'm just going to, and don't worry too much about what I'm doing, this is going to be taught to you in the next video. I'm just going to raise update by 1. Oops, I mistyped that. Oh, I'm sorry, counter by 1. And then I'm going to print out what is being stored in counter. So essentially, each time update is called, this number being stored in this variable goes up by 1, and then we print it. So let's see what happens now when we run it in Unity, and why you should be very careful about doing this. So we can see it going, and I've just been running it for a couple seconds, and we're already at 6,703. So update, that method has run 6,703 times. That's a lot. So we need to be careful about what gets put in update, but it is a very handy method that we can take advantage of. So a little bit about game object components, and this is where we're going to start to kind of tie it all together to learn about how to get our scripts to run and what we're actually kind of doing. So every game object component is actually a script. There are Unity specific components that were written by the company that we can't alter, and those are things like if you select the camera, you see there's this camera component in the inspector. There's this transform component. There's this audio listener component. We can't do any alterations to those. So what we do instead is we create our own game object components by writing C# scripts and attaching them to objects in our scene. So you see I have the demo script. This is now considered a component of the main camera, but it's my self-created one, so I can alter it. This is why we need to make sure that we create our scripts derived from mono behavior. If you create a clean script that is not, like if you've taken C# before and you know how to create your own classes and everything, if you don't derive from mono behavior, you will not be able to attach it to a game object. But the good news is if you just do the right click to create your script, create C# script. By default, these are mono behavior scripts. Oops, I did not open it. There we go. By default, these are mono behavior scripts, so we don't want to mess with this. So, and it does put the void start and void update in there. So one thing I would like to also mention is that when we work with Unity and the stuff that we're doing, we can only see what we can only make things happen when we're in runtime. And you do need to be made aware that any changes you make to your Unity project while you are in play mode get reverted back when you stop playing. And this can be a real challenge if you're not aware of this and you're not keeping track of it, because you can accidentally lose a lot of work. So let me show you. Let me show you an example of this and how to kind of help with this. So let's say I'm playing and I have my main camera and I have my demo script. Oh, and my counter's going up. That's fine. It'll keep going up. And I put my script on there, my other script, I changed my age to 60, and I'm like, oh no, I didn't mean to do that. I need to, and then I hit stop. Notice how my script disappeared off of it. My age went back to 25 and the counter is set back to 0. That's because any changes you make when you hit play, when you stop it, it goes back to the original. So one of the things that we can do to help with this is we can change our play mode tint on our screen. So it's kind of subtle to tell, but when we hit play, it does dim ever so slightly, but that's not very obvious. So one of the first things I do when I install Unity is I go to Edit, Preferences, and I go underneath Colors. So it's just Edit, Preferences, Colors. And this play mode tint right here, I change it to something very obvious. Usually, specifically, I change it to like a very bright pink color. So now, that play mode tint, I hit play, there's no question I'm in play because I see this really bright pink on here. I'm not going to forget. I'm not going to make changes to things because I'm going to see it's pink. I'm going to remember to turn it off before I make major changes. So this was just a real quick overview of C# and a little bit about how we hook it up into Unity to get you started. In lessons after this, we are going to focus in specifically on these different areas, as well as how to write different pieces of code and stuff like that. So if you're still kind of a little bit apprehensive on this topic and you felt that this went a little bit fast, the whole point was just to kind of get you in the mindset of how C# works, with it being the building blocks of programming. So you should have a pretty good understanding of what a variable is and what they're used for. You should now know what methods are for and the purpose of them, and a little bit about classes and objects and how that kind of relates to what we're doing with our scripts. The last thing is we did talk about Unity components and how they relate to everything that we're doing, and how it's important that we need to make sure that any scripts we write end up being a component on a scene in Unity, or else they won't run. They won't have that trigger to go on there. So in future lessons, we're going to go into more detail about the rest of this stuff. So keep on practicing, maybe go back and try out a couple of the things that I typed in, as well as look for extra practice and read the chapter of the book that this correlates to. Will also help you out with this. They have a lot more examples in there, as well as some Unity stuff to work along with.